This one is good, very supple. Yes, the salt cure worked well.
Once sourced ethically as a byproduct of the meat industry, the raw camel hide begins its journey. Fresh hides are highly vulnerable to bacterial decay. To prevent this, they are immediately treated with salt. This process reduces water activity through osmosis, drawing moisture out and creating an environment where bacteria cannot survive. The hide is then graded based on thickness, fiber density, and surface defects. What looks rough and imperfect now holds massive potential. Inside massive rotating drums, the preserved hide is rehydrated, then begins liming a high pH treatment using calcium hydroxide. At pH levels above 12, unwanted proteins break down, hair loosens, the structure opens. After deliming to rebalance acidity, the most critical stage begins: chrome tanning. Using chromium-3 salts, collagen fibers form stable crosslinks. This chemical bonding transforms raw hide into wet blue leather, resistant to heat, decay, and shrinkage. The once perishable skin is now permanently stabilized. Raw leather is far too thick for garments. Using band knife splitting machines, the hide is precisely reduced to usable layers. Then, shaving cylinders calibrate thickness down to 1 to 1.4 millimeters, ideal for jackets. Too thick, and it becomes stiff. Too thin, and durability is compromised. Engineering precision ensures balance between flexibility and strength. Uniform thickness also guarantees equal stress distribution across seams. This is not just trimming, it is structural calibration. Inside rotating drums, aniline dyes penetrate deep into the fiber matrix. Unlike surface paint, these dyes bond within the collagen structure, preserving natural grain patterns. Next comes fat lacquering. Oil emulsions are introduced to lubricate the fiber bundles. This microscopic lubrication allows fibers to slide smoothly during movement. The result? A jacket that bends without cracking. After vacuum drying and moisture stabilization, the leather becomes soft, flexible, and rich in tone. Design meets engineering. Using CAD software, patterns are digitally developed and stress-tested in 3D simulations. Every panel must align with natural grain direction. CNC oscillating blade machines cut the leather with algorithm-optimized nesting to reduce waste. High-stress zones, shoulders, elbows, side seams are strategically reinforced. This is not random cutting. It is calculated structural design. Inside the sewing unit, walking foot industrial machines take over. Unlike regular sewing machines, these synchronize feed dog and presser foot movement, preventing leather slippage. Double stitching reinforces load-bearing areas. Thread tension is precisely balanced. Zippers, rivets, and snaps are installed using pneumatic presses. Each seam must endure tensile force, repeated flexing, and years of wear. Precision here determines longevity. Before completion, the jacket undergoes surface refinement. Buffing rollers smooth imperfections. Spray systems apply thin protective layers of acrylic or polyurethane finish. These coatings enhance UV resistance, improve water repellency, and increase abrasion durability. Heat tunnels cure the surface bonding finish layers permanently. What began as raw desert hide now gleams with controlled elegance. Strength must be proven. Seams are tested under tensile load. Abrasion machines simulate years of friction in hours. Flex endurance tests bend the leather thousands of times. UV chambers expose material to artificial sunlight. Water repellency and color fastness are measured. Only jackets that pass strict industrial standards move forward. Because durability is not claimed, it is tested. The finished jacket receives its label identity stitched into craftsmanship. Carefully packed in dust bags and protective boxes, each piece is barcoded and tracked. Humidity-controlled warehouses prevent moisture damage. Containers are loaded for global shipping. From factory floor to retail shelves. From desert origin to urban fashion. In one of the harshest environments on Earth, where temperatures cross 50 degrees and survival is a daily battle, an animal thrives. But what if I told you that the same hide protecting this desert survivor can become one of the most durable luxury jackets in the world? This is not just leather. This is chemistry under pressure, engineering at microscopic scale, industrial precision measured in millimeters. From raw desert hide to high-end fashion markets, today we go inside the factory to uncover exactly how camel leather jackets are made and what really makes them so strong. At this stage, the leather is strong, but far too thick for a wearable jacket. Raw camel hide can measure up to 6 millimeters. A jacket requires precision. Inside the splitting unit, massive band knife machines slice the leather horizontally, separating it into controlled layers. One steady motion, one continuous cut, no room for error. Next, shaving cylinders refine the thickness further. The target range is precise, between 1 and 1.4 millimeters. Too thick, and the jacket becomes stiff and uncomfortable. Too thin, and durability is compromised. Laser-guided calibration systems measure uniformity across every square centimeter, because uneven thickness creates uneven stress, and uneven stress creates failure. This is not just trimming material. This is structural engineering at material level. Moisture-controlled chambers then stabilize the leather, ensuring flexibility remains consistent before the next phase begins. Now the leather is balanced, flexible, strong, ready for color and character. Color is not applied to the surface. It must become part of the structure. Inside rotating industrial drums, aniline dyes are introduced. As the drums spin slowly, dye molecules penetrate deep into the collagen fiber network. Unlike paint, which coats the exterior, aniline dye bonds internally, preserving the natural grain and texture. But color alone is not enough. Without flexibility, leather cracks. That is where fat lacquering begins. Special oil emulsions are added into the drum. At microscopic level, these oils settle between fiber bundles, acting as internal lubricants. When the jacket bends, the fibers glide smoothly instead of breaking. This process determines how the jacket will age. Will it stiffen, or will it soften beautifully over time? After dyeing, the leather enters vacuum drying systems. Controlled pressure removes excess moisture while preventing shrinkage. The result is material that is rich in tone, supple to the touch, and engineered for movement. From raw strength to refined flexibility, the transformation continues. Before a single cut is made, the jacket exists as data. Inside the design department, engineers use advanced CAD software to create digital patterns. Every curve, every seam, every panel is calculated for movement and structural balance. A jacket must flex at the shoulders, bend at the elbows, stretch slightly across the back. Using 3D stress simulation, designers analyze tension